So my name is Yuning. If anyone don't know me or new to RISC-V, so I'm a software guy. I used to make my money on virtual machine, static compiler, and then I found deep computing during COVID. And then I'm a software guy. If I'm serious software guy, so I make my own hardware. So, and what deep computing does, we make all the consumer electronics. If you go to our website, you take a look, we have make tablet, we have speaker, we all make all those things, no matter how bad the chip is, how bad the software is, but we need to experience all the problems. And then, of course, well, we make the most complicated consumer electronics, well, which is laptops. And then, besides that, I do some RISC-V toys, make RISC-V Live C more fun. So, 2003, once we found it, in COVID, took us 18 months, 24 months to make the first generation 4-core. And then 2024, we make 2 versions again, and with the tablet as well. So it's double the performance, but the software is still no good, and you will see the trajectory. But now I think the software now is slightly better than 2 years ago. If you're running on the same old hardware, probably 2 times faster. So, and it runs Fedora Remix and Ubuntu LTS as well. So in 2004, then we start partnering with Framework and making the motherboard. The reason we partner with Framework, we find my roadmap is that every 6 months we make the motherboard. And then I want my user to upgrade their motherboard. And if I do my own laptop, my customer won't be able to replace the motherboard themselves. So I partner with Framework, which is designed for replace the motherboard, DIY, assembly, fix, all these things. And that was last year we're here. So, and Framework was good. You know, it's just like DIY thingy. And it's good. People have excuses not to use RISC-V. They can, when they do some other work, they still can use x86. And when their hobby comes, and then change it to the RISC-V board, you just need 3 minutes to change it. I think Matt probably do better, 2.5, to change your motherboard from x86 to RISC-V. And it's upgradable. So you can see, we just launched the 8-core AI PC, and now we can see 16-core coming in March. And then more 4 nanometer probably in September, October. Every 6 months, you're crazy, you know. So you can change the board, and then you can upgrade it. So that's how it looks like. The first one, slow one, and then when we back to now with for example, the current generation is the 8-core, it's the AI PC, but the problem is RISC-V is that we are facing an unknown market. We do not know where to go. But AI is certain. AI is certain, it's growing market. So, but we don't know how much compute power is. And the problem with RISC-V is that you can see we are compared to ARM ecosystem with a significant less resources. Probably ARM ecosystem have 10 times more resources than us in terms of money and body and time. So, and we decided, let's go all the way to AI. So, and we give guidance to the SOC guy, hope them all in AI, don't go on to the general OS, Windows, Android. It's too hard, right? So take a look at the chiplet. So it's very flexible chiplet. So this is our solution. So one chiplet is half of the performance. For example, 25 TOPS, GPU, NPU, and then the 2 chiplets connected together by the SerDes interconnects. So it's very flexible. For example, after this 8-core, we have 2 die chiplet. We have mini ITS coming with 4 times of this. And then we connect it with PCIe ring. So because the good thing about this chiplet, they have PCIe 3.0 host and device. So PCIe 3.0, the upstream downstream is reached, should be, if I'm not wrong, it should be 20 gig per second. So it's pretty fast. That's how it looks like. If you guys interested, go to our booth to take a look at the real machine. So, yeah. Then we make this for framework as well. This morning we had done a workshop to demonstrate how we run the 7B model in 10 seconds, 10 tokens per second. It's not fully optimized yet. So it's because we do it for framework, our R&D cost is significantly reduced, and then the cost to the product is significantly reduced. So it's $300 for motherboard in that hardware performance with Fedora, Remix, and Ubuntu support. It's pretty decent, and most likely it's run the local AI models. So now we're getting the hardware half sorted. I would say that it's not fully, compared to NVIDIA. But I think on the hardware, on the AI side, we are pretty close to ARM, except Qualcomm. Because Qualcomm's AI processor is nothing to do with ARM. But for ARM itself, we're very close. So in this moment of time, ARM's AI and RISC-V AI is the same start line, right? And ARM have a lot of legacy on the Android, but RISC-V nothing, brand new. So we are looking forward to RISC-V with matrix extension, all this coming in the year, even better, right? Instead of using offload NPU. So then after we get hardware, now we're trouble. What the hell are we going to use it? Right? So, and the killer application, we lack of any applications. But for ARM, same. On Linux, they are the same. They have none of them. So you think about it, there's no difference. So that's why I'm excited about. And same, ARM doesn't run that good, right? And no one can be CUDA, even ARM. So at least we are underdog, same as ARM. So, and we have a lot of things doesn't work, probably very similar. And then most of the time, like us, we get hardware ready. Now all our resources putting on to optimize the compiler, optimize the kernel, optimize the movement between the data to the NPU. That's what we spend all the time. So then I start finding out, okay, there's so many to do, so which way to go? And then I pick an app. So what app we gonna pick? So we take a look. And then we pick VLC. It's very lucky when this year I was in Folkestone. Then I met the VLC guys. Why not you choose us? You take a look at our demo on our branch. The subtitle works, but we talk to the cloud to get the model running, inference, and speech test, all this. And then, oh, good. So we're trying to turn it into running our local NPU. So what ELC is originally from Paris. They call it Central School. I don't think it's a university at the time. So, and now it's led by JB, and he's a really good guy. And then they have a free philosophies. Free. So nothing better than that. No same as RISC-V, open. We are open, we work with framework, open hardware, then we work with the software. Right? We don't work with the closed software because it doesn't work. Because if you do a collaboration with two startups or whatever, and we have not enough resource, if they close source, that means either there are guys in my office and either our guy in their office. That doesn't work. Right? So we pick. And VLC is pretty good. And accidentally, they announced the support of, have a branch support on the AI for VLC. So it took them 30 years. They reached 6 billion downloads. Oh, my God. So how good is it? So we make it AI. So then we start porting. Realize, man, So what VLC does, so it plays a video, and then we think, okay, let's sort it out the subtitle, and then support multiple language. So especially after the inspiring conference summit in Paris, in Europe, it's hard, man. You have 40 language, right? So I say, let's do it. So if someone do a speech, and then they have 40 language subtitle, depends on where you want to look. So that's my idea. So it relates to the so-called STT model runs on Whisper. And then we do the speech, audio speech test. This by one model runs on our NPU. And then we do a translation run on our NPU as well. And that tests two different language. Just usually we on a local model say French. This sentence, it just gives you French. It's pretty cool. So now we're trying to compile VLC. Jeez, 128 package. And you know, when you compile VLC, it needs so many tools. It's endless. The end is 128. Not just the dependency library of it. It's the tools needs that. The compilation environment is horrendous. So it's very painful. It's truly painful. And VLC is not cross-compile. We have to native compile, even more difficult. Right? So, and of course, and VLC is this support of, it's a demo, it's on a branch. So it's different from whatever release on the x86 on ARM. It's different branch. And we see that most of them not optimized, not even ported. Then we had to, one by one, the package you verify that trying to get VLC running on RISC-V and building. So what we do, we start getting the branch, and then adding support onto Whisper and Llama. It doesn't support RISC-V. So there's no RISC-V library, there's no RISC-V CLI, command line, nothing. You have to do everything yourself. And we had to get the 7B model, runs on the NPU, compile it, pre-compile it, fix it, all these things. So we got all the codec random. Because VLC, we use the hardware codec as well. So you can see when things compile it together, you will see all the randomness questions. All right. It's part of the fun. So, and the SoC guy upgrade the FFmpeg pad, and then VV support, and also with the hardware support as well. But it's pretty bad. You know, the SoC give us the FFmpeg pad library, which is different version of VLC 3.6 depending on. So man, another bad port. So that is the all brickwork doesn't you know, I would say that doesn't improve our intelligence at all. It's the porting. And then after that, because Whisper is supposed to run on cloud, and they only support big model, doesn't support tiny models. So when we put another tiny model on it, so we have made significant change on it. And then because usually we run on the remote cloud server based on HTML or these things, then we had to port the support local MPU. Right? All these are brickwork. So we managed to get it to work, but it's complicated, man. So we add GGML tiny on it, and then we do the set DeepC 7B, and this morning, because the MPU doesn't, you know, I don't know how much memory it needs, because once you have no experience. So the app use this, and God knows how much memory you're gonna use. So the MPU is behaving very funny. Sometimes give you ask for French, it give you Chinese. But, you know, that's AI, right? Just like a kid, you know. You ask me something I don't understand, I give you shit. Garbage in, garbage out, right? So it is. It's in our work. It was in our workshop. and Mary said, "Why are you saying Chinese?" I'm asking in English. I said, chicken talking to duck. But we got it working, you know. So and the SOC guy working really hard under resource. And we're trying to get the Model Zoom SDK. We just got it the week before. So we're going to gradually open source it. Anyone buy our product can help us to improve it, especially all the kernel side. And then all the testing is, you can see it's working. If someone have time, can come to our booth and we can demonstrate it. If it's not broken, okay? So we got, you know, on the translation side, we got 5 tokens per second. And then if 2 GPU weren't enough, not running out of memory, then we got up to 10 tokens per second. It's not bad. The first try, I get an end-to-end solution working, but hard work, man. Hard work. So after that, I think about it. How am I going to conquer AI for RISC-V? I don't have enough resource. So I started, okay, anyone can help me working on their AI apps. I give them hardware for free if they get it to work. Otherwise, they have to buy my hardware. So that's why we're gonna announce the RISC-V support, AI support. Whoever interested, help us to prove. There's 2 reasons for it. One is to help us, the app ecosystem getting in better than ARM. Right? I don't think ARM needs a sponsorship, people get on it. But I think RISC-V, we need sponsorship to build the environment. So then hopefully we can have more AI guy knows about RISC-V, right? Join RISC-V International, and then hopefully we have 100 contributors, then use our hardware to contribute our imperfections. So we give some crazy hardware. So hopefully, yeah. So hopefully next year we get someone here talking about what they contribute to. That's all. Thank you very much. All the hard work.